But what we do have is this Arduino code for the serial input. So we're listening over the serial port. We've done lots of serial print for debugging and things, but this is a serial read where we're going to input data from the serial port. And the serial port takes data one character at a time. So if we're going to send a number like 90, we have to get a 9, and then we have to get a 0, and then we have to know that that's the end. And then we have to put those together to make a 90. So it's not a number that gets sent, it's characters. And so we're getting a string and we're having to parse it into the actual thing. So this code here, serial compass skeleton. And so from the top level view, what it is it's a blank skeleton for compass following. It has all the functions that you need to do compass following that you probably already have implemented, plus new functions to talk to the serial port, to listen to the serial port. So there are things like a buffer to store the characters as they come in. And I tried to make it commented. So my goal is that you probably won't you'll use this, but you'll copy parts and stick them in. But just to show you kind of the layout, this has placeholders for all of the usual functions. So if we skip down to loop here has a new function, check command. So this is the one that's listening for the heading command on the serial port. And then it has a sensor function, a control law function. There's a check if the heading comm is 999, that's a special case for stop. So, so it's got to test, either run the control law or stop the motors. That could be in the control law, I suppose, but it's not how this one's set up. Then it runs the motors with a run motors function. And then I set it up to print here because we're using the serial port. I don't want any delays. You should never have delays. So this is following the print with delay examples, but basically there's a timer that is set to the current time plus 1000. And so it prints every 1 second, but it runs the code as fast as possible. So this, if you haven't used this kind of thing before, it's a nice example of how to do debugging without bogging your program down. Serial printing is very slow. So, so we only print once a second, but we run everything else much faster. So that's the loop. And so really, if you put this function into your code, instead of that timer math, then you've probably got all the rest of these in your code already. So that's the goal. And you can see that I just have sort of empty spots. So the control law doesn't do anything. The read compass doesn't do anything except run motors, just blank for you to, because you already have those. So this is the new one, this check command function. It uses the serial port, and if serial is available, that means something has come in because the Arduino buffers it. It saves it and tells you that there's something. Then we read it. And again, this is a character. It's a letter or a numeral, but not a number like you could do math on. So it saves them into this buffer because it's going to get, 180, 3 characters, and then it needs the end of line. And the end of line here is either going to be \n or \r. Those are the, when you do serial.print line versus serial.print, these are the characters that get added to end the line. So we're going to listen for those. And when we get one of those, then we process all of the numbers into a number. And we use this A to F that takes an array of characters and turns it into a floating point number. And so we just give it the string and it gives us a number. And if it can't figure it out, it gives us 0. So sometimes you get these extraneous zeros. And so I'll show you that. But realistically, if you just call this function every once in a while, then your heading command should get updated automatically. That's the goal. So you shouldn't have to do much besides copy and paste. The other things that are going on here are the buffer index where we're storing things. We want it to start at the beginning and finish at the end. So when we get a number out of it, we reset so that we start over at the beginning. And when we have a new command, we set a flag here. And here is where we take that and store it into SciComm, which is the one that our code is going to use. So if you call this function, it will automatically listen to the serial port and put numbers into your SciComm variable, or whatever you want to name it. And the old code, the timing code is here if you want to switch back and forth. You can uncomment this instead. So let me show you what it looks like. If I've got an Arduino Uno COM11. So if I put this into the Arduino Uno, we can test it out without the ESP32 yet by just running the serial monitor, because it was already running. And it's printing out the heading, which is, there's no code to check the heading, so it's 0. And the heading command is my SciComm here, which is the direction I want my robot to go. So if I type something like 56 up here at the top and just hit enter, you can see it read it. And so that's how you test this out, is if you just put this code in your Arduino and then use the serial terminal, whatever we put in there. And if you put a number that's outside of the range of plus or minus 180, which is our compass valid numbers, then it switches it to 999 as an error. So 999 means stop. That's what this code is doing. If it's not within the range of plus or minus 180, it sets it to 999. So we know that there's something weird going on. But unfortunately, if you type something that's like text, it normally switches to 0 because it's not a number. So the error checking isn't great in here. It does some, but not very much. So we could put more in, but it just gets more complicated. And the ESP32 is pretty good about just sending a number every time. So if I type in 0, I can set it to 0. 90 should work. 180 should work. Minus 90 should work, and go back to 0. So we can do all of the heading commands over the serial port. So I'm typing up here and I'm hitting enter. You can also use the send, I think will do it too, but I usually just hit enter. So that's the code that if you want to try something next, you can try this example code just like I did. I will edit this into the demo that's not listed there, so that you can see how it works. And so testing it out should go pretty fast, should take about as long as it did just now. But the next step would be to integrate this code into your Arduino, save a new version of your compass following code, and use this check command. You can just paste that into your code and then call it in your loop. And everything else you could pretty much leave the same, and you should be able to type commands at the serial port, and your robot will go. You'll have to chase it around with the cable if it's moving. Seem doable?